So from a big picture point of view, and this is really the reason that the UK government were really starting to push BIM a number of years ago, back in sort of 2013 or so. They really decided BIM was the way forward for the UK construction industry. Really, it's got some massive potential. And what they looked at was really this diagram that we're about to go through. There were reports done, and if you can kind of consider the financial outlay at each of these stages, you'll start to see why BIM becomes quite an important tool. So if we look at the design costs, so that's the fees and the costs that a client would incur up to the point of construction. So that's all of your designer fees, consultants fees, application fees, all that side of stuff, surveys maybe, anything else that you do at the start of the project. In the grand scheme of things, it's quite small in terms of the overall construction cost. So if you think the design fees are very small, the construction cost is obviously a bit bigger than that, the capital cost to carry out the build itself. But bigger than that is the operational cost of the building. So after it's been handed over to the client, that building is maybe being used for 50, 60, 100 years. And the cost of running the building, maintaining the building, replacing things that fail, upgrading things when they need to be upgraded. The cost there, the government realized was actually huge, far bigger than the design cost or the construction cost. And the government, certainly in the UK, the government are a big asset owner. They own an awful lot of properties, buildings, infrastructure, assets. And so they're bearing the cost of running all these buildings, which are, to the large part, probably ineffective, inefficient, not designed with operational stuff in mind, designed to try and get it through with the cheapest construction cost. So this is not a good way to think about procuring buildings, and BIM is a solution to this. So the idea being that if you have a think about the end goal, that actually it's the operational end of the building that's going to cost the client the most money, and work back from there, BIM can bring in an awful lot more benefits to the client. We'll have a little chat later on when we're thinking about handover information this afternoon about a process called soft landings, which you've maybe heard of before, but that kind of chimes right into this concept of preparing the client and the building for handover. So it's not looking at what's cheapest to build, but what's looking at most efficient to run as a building. So this has been the kind of current focus for the UK government for a while now, as I say, sort of since the roundabout sort of early 2010 or so, and shortly after there, they identified this. And using BIM as a tool to engineer a more efficient building through the process is a great benefit, of course. But now that we're starting to get more familiar with BIM and the technology and the benefits, the potential that comes with understanding buildings better and realizing the data that comes with those, and looking at exercises like post-occupancy evaluation, feedback from people that use the buildings after handover, we can start to feed all that back in again. And we can start to generate bigger benefits, financial benefits for the construction industry and the built environment. Bigger than the operational costs for the building are the potentially the business costs. So this would be the cost to a business of working in the building, for example. If it was an office building, how much does it cost that business just to use the building? Never mind replace things, but actually just to be there. And actually then the even bigger potential benefit for here is the outcomes of that business. So if the building was able to be designed in such a way that you were able to make people happier in their environment, healthier in that environment, that they're therefore taking less time off work due to illness. They're potentially, if it's a hospital building, that actually you're using the technology and the understanding of the digital design stage from the digital building to basically refine and engineer those spaces so that people in hospitals get better quicker than they might have done before. If it's a school, maybe it's that people get a better learning experience and therefore they're able to pick up things quicker and pass exams the first time round. Understanding that digital stage in the process to really refine that at that early stage can bring huge benefits to projects longer term. And that, as I say, that in a nutshell is really why in the UK, the government have been pushing BIM as a requirement. So public contract projects in the UK have had to work to BIM as a process since 2017, 2016 in England, and 2017 in Scotland. And it is really because the government had realised that if we get this right, if we understand the built environment better, we can really achieve some significant savings and improvements, not only financially, but also in terms of health and well-being, people's happiness and these things as well, which are very noble goals, you know, difficult things for the construction industry to achieve, where so much of it at the moment is driven by construction cost, capital cost. Another way to think about that kind of ongoing cost is to kind of break down, I suppose, the building's life into a series of events. So if we start with the initial design construction of the building, the concept, design, construction, and then handover, if we think about that as a single circle, that's the project life cycle there. So we get round all the stages and we get to handover. The bigger circle on this diagram is the rest of that building's life. And each of the little circles, the little blue circles round about, are little projects that need to be done throughout the life of that building. So if it is a building that has 60 years of use, say, each of these little exercises might be replacing the doors and the windows, replacing the heating system in 20 years' time when it's out of, it's no longer efficient. It might be putting on an extension or doing some alterations to that building to make it suit the needs of the users as it goes on. So there is much more expense and time taken in a building's life. 30 plus years is a conservative estimate, I think, in terms of a building's life, compared to the 1 to 3 year initial construction, design and construction phase. And again, it all chimes into the longer term goal, that it's not just about building it, it's also about maintaining it and running it. And the big swing here is the difference between capital expense, CapEx as it's known, and operating expense or OpEx, and getting clients, I think, to look at the importance of the ongoing costs of running a building. I'll save you from a full-blown rant that I have about the UK procurement system for procuring certainly public sector work, which is all driven by capital expense. Really, it is about what they consider to be value for money, and therefore it tends to be the cheapest. Whoever offers to do it cheapest tends to get the job. But in offering to do it cheapest at build stage, during the rest of the building's life, the components will probably need replaced more often and earlier. They're maybe not as suitable. It's not going to do as well for the people living and working in the buildings. So there's definitely a balance, and hopefully the BIM evolution, I suppose, as it's kind of going on, will convince the decision makers in government that actually there's a bigger win here, that if we think about the full life cycle of a building, not just the construction cost, we can really achieve some really big benefits. And it's all possible from this kind of digital approach. Obviously, a key benefit of working in this digital model-based environment is to be able to do clash detection. It's something that you mentioned earlier on yourselves, to coordinate all of the elements in the building. So this is actually a screenshot from Navisworks, which is the Autodesk coordination software that I'd mentioned before. So in this case, we've got a steel beam in green and a cable tray, some kind of containment in red, and you can see that they've bumped into each other. They are occupying the same space in the middle of that diagram. So Navisworks as a platform, as a package, can take the structural model with the steelwork. It can take the electrical model in this case with all the containment models, overlay them on top, make sure that they're aligned, and then it will basically just look at them and it will flag up to you everywhere, every location where these elements bump into each other. And you can do it either like a hard clash, as we would call it here, where elements are in the same space that physically could not be built. You can also get the software to look at what we call soft clashes. So that might be tolerance around about components. It could be space in front of a door for the door to open and close, or a window to open and close, where there might not physically be anything to bump up against in terms of the model, but someone would have to stand there to operate something. It might be a piece of equipment. So you can model activity spaces around components, quite useful for mechanical and electrical installations that require panels to be removed, filters to be changed. If you need, you can't put a wall against certain sides of pieces of equipment because you need an activity space around about it. All of that can be modeled in the 3D environment, in your 3D model, and then this software can flag up if you've got a partition that overlaps that, for example, and therefore it wouldn't work in the real world. So it's a really, really great bit of kit. It takes some configuring to set it up so that it's going to work properly for you, but once it's set up, it's great at identifying all these things, and they're all the things that would cause problems on site, all the things that, those are the kind of elements that you would get a phone call about, that the contractor would normally say to you, this doesn't fit, this won't fit in this space, or this is going to clash with that. And they expect you to come back with a solution, which takes time. It means that things aren't moving as quickly as they should. It's wasting materials because they'll have ordered stuff that may no longer be able to be used. It's just not a very efficient way to build. This is another benefit. So this is something that you touched on earlier on, is about sequencing of the works. So again, this is Navisworks, a screenshot from Navisworks here. That once you've got the model in Navisworks, you can basically break it up into work packages. So it might be, in this case, the model is kind of half built here. You can see the external walls are being built in a sort of sequence. The green one that's floated on is going to be next. And at the bottom of the screen, you can identify times to each of these components. So you can look at work packages, elements within work packages, give them an anticipated start date and end date, so you know how long it's likely to take to put that piece of equipment in, or to install the slab, or to erect the steelwork, or whatever it happens to be. You can break it down to as much detail as you need for the project, and then you can run a little animation and you can watch the building be built, and you can stand inside the building, you can put a camera inside and you can watch it build up around about you. You can then explore on a particular day, because you put in actual dates. You can then say, okay, well, on Friday the 21st, what should be built at that stage according to the program, and the model will show you at that stage, and you can compare that to reality, so you can get a good track on the progress on site. Really, really useful tool. As you can imagine, it does take a bit of time to set that up, to configure it, and to kind of package up, portion off all of these elements in Navisworks to make that work. But once the design is pretty close to being finalized, that can be done, and then it's there for the life of the project. And if models are updated, the way that it works in terms of element tagging, element identification system between the CAD, the BIM software where you build the models, and Navisworks, elements will keep the same tag. So even if something moves or changes, it'll have the same tag, it'll keep the same programming attributes when you come into Navisworks. So even if a design changes, the programming should still sort of flow through. Something else that Navisworks can do, and there are other software platforms that can do this as well, is the quantification side of things. So once the model is built, you can then use that to extract quantities for materials, either of individual components, or the amount of concrete that you would expect, the weight of the steel that you would expect, all of the data that you've put into the model. This is one of the ways you can extract that and use it for another purpose, to be able to do something with that. So again, at the bottom of the screen here, this is how Navisworks starts to categorize elements. You can you go into the model in Navisworks and you identify whichever elements you want. You can associate costs to those. So it might be a cost per cubic meter of concrete, for example, might be a cost that you've got from your supplier. You can go in, it'll be able to tell you how much concrete you have, and it'll give you the cost for that. And obviously, as a design changes, it just updates instantly because it's all looking at the same information. So again, another really useful tool. Navisworks, I find Navisworks quite clunky for doing quantification. You need to really spend a lot of time configuring the quantification part of it. There are other software packages that are specifically designed for quantification. They take the model and they break it down, and as long as it comes back to what you said earlier on, as long as it's all been coded properly in the BIM model, that you know, the BIM model has the correct coding for concrete, say, whether it's an in situ concrete or it's a precast concrete. As long as that's in the model, this quantification software can extract that and populate the costs quite quickly. But if somebody hasn't coded things correctly, you garbage in, garbage out, it doesn't come through properly. So it's all about checking and making sure that all of the information is correct. So some other benefits then, we'll just kind of sort of run through some of the kind of key things that will come up on projects where BIM has been used. Clearer client and end user expectations is a big one. So quite often clients don't necessarily understand drawings. They can't read a plan. They maybe don't really appreciate how big a space will be. Being built in the 3D environment, you can apply all of your materials. Your interiors team can dress that space in the model the same way that it would be dressed in real life. And these things the model can quite easily plug into virtual reality headsets or 360 renders so that you can actually send that to a client and they can look around. They can really give you accurate feedback at that early stage to say, maybe that window's not in the right place, or actually, do you know what, that material is going to be too dark there. Maybe we should look at something that's lighter. All of that's done early on. And it really appreciates when you get to that handover stage, the client then understands what they're going to get. And therefore, there are fewer arguments at that stage when they maybe misunderstand. Space planning is a big one. And being an architect, we work with M&E engineers who are other consultants, other practices. They're often not involved at an early stage, at the design stage, when we're looking at concept design. And they usually criticize me for not leaving them enough room in a building to fit all of the equipment that they need. Usually I'll allow a plant room of a certain size that I think will be sufficient, and they'll come in and tell me we need about 3 times the size of that. But having them appointed early on, having them involved in that model sharing exercise, as the design is progressing, they'll be able to advise earlier how big this equipment needs to be. And FF&E, so that's fittings, furnishings, and equipment, basically all identified prior to construction. So if the client has a particular reception desk that is going to be installed perhaps in an office, you can make sure that that's coordinated with the rest of the design, lights are in the right place, all these other things that need to happen can be done in the model. We've talked about late issues, problems on site, being more rigorous at design stage, the prototyping thing. Drawings between all the disciplines align and coordinate, that's a big one. So because we were able to overlay all the models on top of each other, and then make sure that go through that clash detection process to make sure everything is got its own space, then all of the elements should align. In the UK, I'm not sure if it works the same for you, but in the UK, what traditionally happens is when the architect reaches a certain stage of the drawings, the structural engineers say will produce their drawings based on the architect's drawings. And if the architect's design then evolves and changes as it gets more detailed, that'll update. But rather than the engineer updating their drawing every time there's an architect's update, they kind of just, well, it's pretty close. We're happy with what we've got. The contractor, when they come on, they'll do their own set of fabrication drawings, so that'll get caught. Any little discrepancies will get caught. And it just means that things are out of sync, which is not a good position to be in. Because you're working in that constantly evolving 3D model environment, that kind of thing doesn't happen on a BIM project. Everything is updated as you go through. And we've talked about the accurate handover information before. Housing is an interesting sector to look at the benefits for BIM, because certainly in the UK, the BIM, I think, has a perception of being useful for large, complicated projects like high-rise offices, complicated M&E fit out like your courthouse project. Those are the projects that I think people have always thought that BIM is, that's what BIM is for. However, I've done a lot of work in housing, multiple unit housing, low-rise flatted blocks in the past, and there are huge benefits for housing as well using this process. What it's allowed us to do for our clients is to develop a really refined range of standard house types. So when we were working for a house builder, we've been able to prototype and refine that 3D model for each of their house types really to quite a high degree, so that it coordinates exactly. And it means if we're then looking at a future development for them, all of that information is there. We can just drop it onto the sites and arrange it really quickly. You can build in rules to the models to demonstrate compliance with regulations. And one of the things that, when we come on to talk about checking the model later on, one of the things that we'll talk about is a piece of software that basically allows you to build rule sets. And then you can actually use that to check your models. So great for housing, because in the UK, again, certainly publicly funded housing needs to comply with certain rules around about room sizes, activity spaces, window sizes, these sorts of things. So you can build rules in that you can check the model against and make sure that actually that still complies. It's removing the risk of somebody missing something as part of a human checking process. Quicker costing, so we've talked about the quantification, site layout appraisals, I've mentioned that. Integration with off-site manufacturing and design for manufacture and assembly. So again, it's taking that refined 3D house type, making sure that it is coordinated, that it basically just plugs into the factory's systems, that when components are built in the factory that are then assembled on site, all of that is already coordinated in the 3D model. Better handover information for the new home, so perhaps not for the building owner if they're a housing association or a local authority, but the resident, actually giving them better information on how their new home works. At the moment in the UK, it's certainly pretty patchy, not very consistent how new homeowners get information. It gives a more accurate starting point for future work, so it's not uncommon for houses to be extended and altered for elderly people who maybe need ground floor toilets or chair lifts or larger rooms and things to be done at some stage in a building's life. So having the digital version of the building there to start from means there's no guesswork. Small projects is an interesting one. I'll maybe just rattle through these quite quickly, because again, it's something that people don't often think about for BIM, because it sounds quite, there's a lot of specific terminology for BIM. I think a lot of people who work on small projects feel it's quite alien. It's maybe not for them, but it really is. I actually suggest for companies that are looking to get into BIM that starting on a small project might be easier than a larger one, just because there are fewer people involved. It's maybe a more straightforward design. You're not having to deal with massive file sizes. It's a bit more manageable. So sometimes it's an easier way in. You can get accurate 3D views of anything, and it goes back to clients' perceptions and understanding what they're going to get. We work in our office as architects. We do quite a lot of work for private homeowners, and not one of them can read a floor plan properly. So to be able to drop a camera into the model and let them look around is just invaluable as part of our process. Quickly assess those design options, instant quantity and cost updates. We've talked a bit about that. And then obviously scheduling the material quantities to reduce waste is as applicable to small projects as it is to larger projects. And it's something that we're all aspiring to as we realize that the way the world is and the way that we're going from a carbon point of view, looking at material quantities, reducing construction waste is a really big thing. All projects are really looking at that. Existing buildings is something that was probably going to be of interest, because you had mentioned a few refurbishment and sort of facade projects that you've been working on. So again, the process applies equally well to existing buildings as it does to new buildings. The challenge is, and I've worked with clients who want to digitize their building stock, the challenge is doing it in small steps. So updating the information as you have it. So quite often, you mentioned it before, Philip, that the information you were given, historic information, wasn't accurate for utilities, underground infrastructure. The same thing happens with existing buildings. So we do a lot of work in Glasgow in Scotland. There are an awful lot of tenement buildings, these sort of sandstone flatted buildings that were built probably about between 150 and 100 years ago. And they are very often the only drawings that exist are the old paper, or in some cases fabric drawings that exist in the archives. So you can't always rely on that, because people will have done things to those buildings since they were built. So making sure that you've always got the most up-to-date existing information and trusting that is really, really important. So it may be that the starting point for an existing building is doing a survey, and that could be a digital survey, like a laser scan, to make sure you're capturing that information accurately. It may be disruptive surveys to work out where services run in a building, and trying to chase things through to work out where pipes are and cables are and things. And then obviously as you build up, as you survey and gather that information, it just all gets added into the model, and you start to build that accurate starting point that when you then go to do whatever work it is that you're wanting to do, if it's fabric improvements, so if it's looking at the facade of a building, you know that you've got an accurate starting point. We did a project probably about 18 months ago with a company that was looking at doing some stonework repairs to a building in Glasgow, right on the main street, very busy road. It was quite a tricky one for them to assess. The way that we did it, we worked with a drone survey company who was able to survey the building both from the ground but also from drones, so we got the full height of the building really accurately. And the drone was able to take high resolution photographs as well, so they were able to, before they even erected a scaffolding, they were able to assess which elements were likely to need work, plan better for that type of work. And then when the scaffold did go up, they were much quicker at doing the job because they'd done so much assessment in advance. And the 3D model, the scan that came from that, was also able to give them a better idea of the material quantities that they needed. All that information came from the digital process that they followed. So it's definitely a system or a process that works for existing buildings as well as new build. So let's look at some project examples of where BIM has been used and the project or the client or the contractor have found a benefit from following that process. So this is Inverness Royal Academy. It's a school up in the Highlands of Scotland, £24 million. It was done a couple of years ago, I think now, and they followed a BIM process throughout the development. So these are some of the benefits that they realised, and I'm just going to make my menu smaller here so that I can see that side of my screen. So they used the 3D model for a range of different things. They used it for visualizations, renders, and certainly Revit and the BIM modeling packages will plug into tools like Lumion for doing renders. So if that's the standard of the quality of image that you're used to producing, you'll still be able to do that if you switch to a BIM platform or package. So they did that for stakeholder engagement. Being a school education facility, there were a lot of stakeholders, I think, so it was quite good to explain not only to the decision makers and the clients, but also to teachers, pupils as well, to kind of explain what was going to happen. All of the services were coordinated with the structural elements. All that happened in the 3D model. The production information was auto-updated, so we kind of covered that when we were talking about the process of the model development. And what they reckoned, and the team reckoned, that hundreds of issues were picked up and resolved through that clash detection process that saved them 3 months construction time than they had. And this is coming from the contractor, able to compare this to a non-BIM project of a similar type and a similar size. They reckoned that they saved 3 months worth of time on site because they followed the process and were able to deal with a lot of those issues early on and resolve them on the computer before they got onto the site. So some pretty impressive figures. This is another example from Scotland. This is it's a huge project, this one. This is the new St James shopping centre. It's got shops in it, it's got offices, there's residential apartments. It's mega. It's £1 million worth of construction work. It's just vast. Right in the middle of Edinburgh city centre. So it's a very prominent project, and there are a lot of people who are looking at it in terms of what it's bringing not only to the economy but also to the built environment in that part of the city. Needless to say, it's being delivered through BIM. Again, they're using the 3D model for drawings, the visualizations. They're using this with virtual reality and using that as we touched on before, for feeding into design for manufacture and assembly. So components are being built in factories from the model that are then brought onto site and bolted together, essentially. They noted that the design for manufacture and assembly process front loads the design and construction program, but it provides that high quality geometry for coordination. So even though the kit of parts is being built in a number of factories elsewhere, the 3D model gives them the confidence that when they all arrive on site and are fitted together, they will all coordinate. That's all been checked, all been done on the model, so that the build time, the time on site, is reduced because so much of it is front-loaded. So yeah, that's the third point, shortening the design and the construction period by using the process. And the progression of that, the level of detail and the level of information that we mentioned, so the complexity of the model within that single BIM environment allowed them to design quite closely, a closely coordinated design compared to a standard 2D workflow. I mean, the project is so big that the number of drawings that they would have had to produce to check coordination between all the disciplines, if they weren't working in a 3D environment, is just mind-boggling. You just couldn't imagine the challenge that would have faced the team for what is a very modern and complicated building to coordinate all of that, excuse me, in 2D. So they found huge benefits from it. And I know from speaking to the architect for this project that they've taken the level of detail in the model really to a really high standard. They're modeling right down to the stage of individual cladding panels. So for if they've got cladding boards, they've not just said this entire wall is a cladding system, this is the material. They've actually modeled each one individually with the gaps and the junctions and things. A huge amount of detail in this model to make sure that they're comfortable with what's happening. That's more than most projects would go to. I have to say that's quite exceptional. But that is what they feel the project required in order to deliver that. So as I say, during the coffee break, I have thrown in a few more civils focused projects. This is one in London, which is a massive infrastructure project called Crossrail, where they're basically adding new subway lines, underground lines to the London Underground network. Mixture of overground and underground trains. I think about 12, maybe 15 new stations being put in as well. It's huge. The project is just vast. But they've realized the benefits of a digital BIM-focused approach. And they're then looking at that as a tool to better deliver the project and de-risk it. So they've got, you can see here on the screen, this is an image of some of the underground buried infrastructure. Some of this is owned by the railway authority, the transport authority that control the network, but obviously being underground, they're also dealing with sewer networks, they're also dealing with other utility providers, power cables, gas pipework, water pipework, all these things that they need to navigate through to get their new subway tracks in. And so they did an awful lot of work early on to establish how accurate that was, to survey all of that properly, and then use that to coordinate the design. And in some cases, I believe that they are millimeters away from the foundations of buildings, from existing infrastructure that's already there, that they've come exceptionally close to in order to put them in without disrupting other things. It's an incredibly impressive exercise. Now, I thought I would be adventurous and try a video. I'm hoping that my internet connection this will be smooth enough that you can see it. If not, I can share the link with you and you can watch it yourselves. But this is a video that shows basically the BIM process that they went through for a new road junction in central Scotland. So this is on a major motorway, highway that we've got running between the east and west. So they used the digital model to design, understand all of the elements that they had to put in that were new, but equally how to then coordinate around the existing road and the existing infrastructure and challenges. And they used the model to do this sort of programming sequencing exercise to make sure that they then did a traffic management plan from that model as well. They could understand what lanes had to be closed at what times to facilitate construction. And obviously with all of that being part of the same model, they could be very accurate in terms of timescales for how that was going to be delivered, and to be able to track that throughout the construction. So that's actually the 3D model there of the junction and the interface, but it came from, they did start with a very accurate survey. So hopefully that was clear enough to kind of see that. I can share the link with you because it's a link. So there's a video online of that I can share with you later on. And then this last one is a school project, not as big. It's about £50 million, so it's not a huge construction project, but still a complicated building with lots of things going on. This is for a new high school, primary school in one place. And again, this is a video that has been produced for this project that I think is really good at showing the different models all on top of each other. So before I click on it, I'll explain first. It starts with the finished building, as you can see on the screen here, and then it starts to just almost turn off individual models. So you'll see the furniture will turn off, then the services will turn off, and the architectural model will turn off, and you're basically just left with the structural model. But you can see how it's all built up on top of each other as part of that coordinated process. So hopefully this, hopefully this will come across quite smooth. We're all working from home here, so I'm relying on my home internet, and it's not as good as the office one. So you can see here that the furniture is a separate model that can be turned off. They've got the fabric from the architectural point of view that can be turned off, the services with the lighting and cabling, and then the structure with the floor slabs and the roof deck, and then left with the steelwork there at the end. So all of those were separate models. They all existed on top of each other to create the overall building. Again, a link here to the Scottish Futures Trust website. There's an awful lot of case studies and other examples, mainly Scottish, of course, but there are some good examples there of other projects and some of the benefits that they found. But I can send you links to some of the others that I am aware of. Great, right, so let's do a quick look at the model. I think I have to stop sharing, and then let me find the model here. So what I've got is a 3D model. So this is in Revit that I can share with you here, and I can just show you a little bit about, I suppose, how it works, how the drawings are produced from the model. As I said earlier on, hopefully the interface is not unfamiliar to you. It's Autodesk have been trying to align all of their software packages for a while now to make sure that they all follow a similar process with the tools and the ribbon and so on, with the viewports and the menus at the side and things. Let me see if I can hide this thing at the top. There we go. Okay. So this is a swimming pool project that we're working on at the moment. It's due to go on site in the next few months. We're nearly there with the contractor agreeing the tender price. So this was an existing building where we're doing some work to extend. So effectively we have an extension out the back of this building here. This is a big extension into the courtyard and a new entrance extension. So within the model we can control the phases. So something that you mentioned earlier on for maybe some of your more complex projects where they're multiple phased, the model is clever enough to be able to break up phases. It understands what is phase 1, phase 2, and phase 3. In this model, we have 2 phases. We have the existing model, which looks like this. So this is the existing building, an existing entrance canopy here, little entrance vestibule into this building that's going to come away. And we're going to build a big extension out the back to increase the changing facilities and a new cafe into the courtyard and a new entrance. So by toggling in the menu here between existing and new, you'll see that it switches and all of the new components come on. So this allows you, again, when you're scheduling information, to understand that, you know, your window schedules, for example, you don't need to show all of your existing windows because they're not changing. They're going to stay as they are. You can filter the information to just show you phase 1 or phase 2 or existing and proposed, whatever it happens to be. So as I say, the drawings for this model, this project, are all taken from the model. So we have obviously all of our floor plans. Floor plans are just taken as a cut through the model, so we can change the height of the cut so that you can see different things within the model itself. Again, you can change the view, the phase settings, so you can show both. You can show existing and new at the same time. So you can see here we've got the existing elements which are being demolished in red. So that information is still in the model. It still understands what that is, and it's able to then show quite quickly what are the differences between existing and proposed. So from a contractor's point of view, understanding the extent of the work, sometimes how things align, is really, really straightforward with this type of tool. I'd mentioned earlier on that details and things come from the model, so we should have, let me find here, sections. So we do have a few general arrangement sections through this model as well. So this is just a section through the swimming pool in this case, and the kind of our new changing extension out the side. And again, this is all coming from that same 3D model. So if I move or delete or add something in this view, it will update in every view, every other view of the model, because it's always looking at that same information. It's just it's just showing you in a different way. We do have as well our details, construction details in this model. So this is a detail between the ground floor slab and the wall, the external wall. We have some timber cladding in this part of the building. But you'll probably see here, if I can select this, this is actually our 3D floor element, which is shown in this model. So this view is actually just a section zoomed in to that one part of the building, and we've just cropped the rest of the building off. In fact, I can probably, I'll turn off the crop so you can see where it sits in the rest of the building, because the rest of the information is still there. That's where this detail sits in relation to the rest of the building. All we're doing is just hiding all of that. And effectively, to give the construction information, we're just drawing on top, in very simple terms, we're drawing on top of the 3D elements. So in here, we should have, if I can select it, that's the wall element in Revit, which identifies each of those layers of the wall construction. So we've got our cladding, our air gap cavity, our sheathing board is a timber frame building here. So we've got our structure layer, and then on the inside, a service zone and a sheet of plasterboard to finish the room. That's what's modeled in the 3D model. And then everything else that you see on this drawing here, the membrane lines, the insulation, the battens and timber cross sections, all of that's added on top. So we don't bog down the 3D model by modeling everything in 3D, which could become very heavy, quite high in terms of file size. What we're doing is we're saying, from a 3D point of view, we need to know the thickness of the wall and the layers that it's made up from. And then actually, from a construction point of view, we just need to know how the membranes all lap together, what's sealed, what are the junctions, the flashing there over the brickwork, and so on. And all that's just added in 2D. So each of these is just a 2D component drawn on top. So we can then change these in the 2D view without upsetting anything else if anything needs to change. The membranes are just lines drawn on top of this just to explain the actual construction process. The other thing I'd mentioned, I think, before was that you can drop in cameras and you can see views of anything. What we find is particularly useful in working in 3D is it flags up to us as designers junctions and relationships in the construction that maybe if we were only working in 2D, we might not be aware of. So there's a big, for example, in this project, there's a big funny internal roof thing that happens in here, which is very easy to forget when you're looking at a plan, because the plan looks nice and straightforward. I do actually have a section through there. In fact, I'll just show you how easy it is to draw a section. If we just draw a section through that part of the building and then jump to that view, which it will have called section 1. You can see in here that that part of the building has this big soffit, and then above the swimming pool, there's this huge volume where it sort of steps back in above that area. And it's very easy to forget about that if we were doing any work in that location. So being able to throw a section through quite quickly and see that relationship as you're making changes in other places is, from my point of view as an architect, just invaluable. And similarly, you can put cameras in. So if we wanted to see from the swimming pool what that looks like, we can quite quickly throw in a camera and you can just see, look around. And again, all of the information that exists in the model exists in all of these views. So if we were to select that door, click on that door, all of the information and attributes related to that door we can find in this model. So this is an internal double door. We've got the size there in terms of the type of door that it is. You can add, we haven't added in a lot of the data for this one yet, but the information is here that you can add in finishes, closers, handle types, locks. I think that's probably because it's an existing door actually that we're keeping. We haven't added that in. Let me find one that is a new door. That'll be a new door. There we go. So there's a new door off the foyer. So you can see here we've added in what the closer type is, what the handle type is, the lock information, signage that goes on that door. All of that is digital information that exists in the model. So when we produce our door schedule, that will all appear and it's kept up to date. There's also information that exists in this menu as well, just a different type of information. So again, we've got material information from a rendering point of view, all the different dimensions and information there that we've got in terms of the construction of the door. So elements that we might need if that door is going to be manufactured off-site. Some of the identity data. So this is where we start to look at if this model was to be shared with others and we wanted to make sure that we had classified elements appropriately. We have numbers and titles in here that we can allocate from the UK classification system, which we call it Uniclass or Omniclass in this case. It's set up ready for Omniclass. We can allocate the correct codes so that if the point we made earlier on is if that was then taken into quantification software, for example, it would understand what that was and put it in the right place. So you can see there that the data all exists inside that model. And in fact, I'll show you the door schedule as well, just to let you see how that looks. So this is a schedule of, oh, that's the legend, that's not the schedule. Here's the schedule. How all of that information then sits in schedule format. So this is the schedule that is created by Revit. So this isn't all typed in information. You can see here, for example, all the doors, we've got given a door reference number. Revit knows where that door is, so it knows what the rooms are. It knows from one room to the other, so you can identify where it is. Panel width that comes from the size of the door. Fire rating we can choose. So again, we can drop down here and change from one type of door to another. All of these elements are based on the data within the model. So none of this is typed in, none of this is live text, if that makes sense. All of it's looking at that particular component and extracting the information into this table so that when we share that with the contractor, all of it is consistent. We know that there's no risk of somebody mistyping something because we can go through and check it. And as long as we've checked it in one place, whether it's in from the plan or from the schedule, it'll be the same throughout. There's no risk of duplication. Is there anything else you would want me to show you just while I'm in the model just now and have a look at? Does that all make sense? If you guys are doing 3D AutoCAD, a lot of it will be similar. As I say, some of the tools and things are probably quite familiar already. The key thing with the BIM element is the data and the kind of non-graphical side, I guess, and that's what makes it a much more powerful tool to be able to schedule. And you can schedule anything, absolutely anything out the model. I've run schedules for brickwork before. I've run schedules for concrete. So if you're looking at the total new floor slab area, you can run schedules for that. It's a really, really powerful tool to be able to understand what you're designing. And when you then think about looking at material use and minimizing waste, that's where you can start to engineer and refine the design proposals to try and save on materials or maybe reduce the amount of concrete you're using or whatever material you're keen on reducing down.